Dear students, Jai Hind and very good morning and welcome back to our revision session. As you all know, we have been revising in our previous lecture some of the examples regarding area of trapezium, where we have solved such type of examples whose length of the parallel side and length of the non-parallel sides were given. And as we were given the length of parallel and non-parallel sides, we found the area of trapezium. Now in our revision lecture number 2, which type of examples we are going to target? We are going to target such example where you were simply given a diagrammatic presentation of trapezium, where you may be given one parallel side, two parallel side, two non-parallel side given, one parallel side was given, and you have to find the area. So, what is becoming important in today's lecture is just understand the diagram, just understand what is given in the diagram, but then also, dear student, one more thing, stick to the basics. That is, if you want to find area of any trapezium, you need to have the length of both the parallel side and you need to know about the distance between two parallel sides. That is what we are targeting. Okay? Some of the examples involving diagrams, okay, in today's revision lecture number 2 for the chapter, as you know, understand mensuration, and in this particular chapter you are attending revision lecture 2 today. Understood? Where we are going to solve some of the example not given in verbal format but given in the form of diagram, and then let us try to solve them. Understood? See, first example, find area of trapezium. This is the question. Find area of trapezium as shown in figure. Okay, you are given one figure. You have to understand what has been given in the diagram, and from that you have to find area of trapezium. Okay, this is the diagram. Let us draw trapezium. Okay, trapezium doesn't look some standard diagram which we have drawn in previous lecture in two example. Doesn't stick to that trapezium is always drawn in that way. No, in trapezium one thing has to be very clear, that in trapezium only one pair of opposite sides should be parallel and another pair of opposite side should not be parallel. These are the concept you stick to when you draw the diagram of trapezium. Okay, let us draw trapezium. It is shown in this way. This is trapezium. Okay, it is shown in this way. This is also trapezium, dear student. Just following the concept that one pair of side has to be parallel and one pair of side should not be parallel. This is trapezium. We are given trapezium this way, and in the trapezium measurement has been given. This is given 13 centimeter. I am not writing centimeter, but just for the sake of understanding, this is 18 centimeter, and this is again 13 centimeter. Okay, now dear student, data has been presented here. First you just try to look at the given data. From the data you have to solve this particular example. Whenever you solve any example, what I have just suggested in our previous lecture, stick to the basics. If you want to find area of trapezium, what you should know, you should be in the knowledge of length of two parallel sides. Here you have AB and CD are parallel side, AB 13 centimeter, CD 13 centimeter, but you don't know the distance between the parallel side. Neither the diagram will give you any comfort to construct. Suppose you if you are logically thinking of those previous example and you construct one parallel side, but this measurement you don't know. So, dear student, conceptually, see one more thing. One example which I will conceptually and in detail explain to you, and then you have to try to solve another example of the same type in SLP with me. Understood? So, what we require to do now, dear student, try to understand. We want to find area of this trapezium. Let us do one thing. Let us construct one side parallel to AD, though AD is not given, then also let me say it E. Okay. Now let us try to solve and understand this in detail. What to do now? BE is already parallel to AD. Try to understand, dear student. If I am able to find BE, I am able to find the area, because BE represents distance between two parallel sides, that is AB and CD. So somehow, if it is possible that I am able to find BE, it becomes easy for me to find the area of trapezium. How can I do it? This is, at least my dear student, not parallelogram but rectangle, because AB parallel to DE, BE parallel to AD, and as you know, opposite sides of even rectangle are always congruent. So this is 13, dear student. So this is also 13. AB 13, DE 13. DC is 18. So 18 minus 13. This is 5 centimeter. Okay. You understood this? Now, after this, as in previous example, you all know, after drawing altitude, as we were doing in previous example also, after drawing altitude, your complete concentration has to be on this triangle BEC, and you should try to imagine how can you find BE from triangle ABC, because triangle BEC is now right angle triangle, and in right angle triangle, when you want to find any side, you can apply Pythagoras theorem. So dear student, we are starting example by applying Pythagoras theorem in triangle BEC. Okay. So the first step of the sum. These are some difficult example. So we are moving stepwise. First step, that is, you just write as per, you need to mention this, as per Pythagoras, okay, as per Pythagoras theorem. Can you mention me the triangle? In triangle BEC, Pythagoras theorem, dear student, to be presented from hypotenuse, as you all know. So let me write BC square equal to, just concentrate here, B equal to BE square, just concentrate there, plus AC square. How I have written Pythagoras theorem? Because some query came from some of the student that they are not in knowledge of Pythagoras theorem. So dear student, mind this, whenever there is a right angled triangle, you can apply Pythagoras theorem, squaring, taking the square of hypotenuse equal to sum of squares of remaining two sides. Understand? Here in triangle BEC, BC is the hypotenuse. So BC square equal to BE square plus EC square. Okay. Let us substitute the value. What is BC? It is 13. What is BE? We are targeting to find it. What is EC? 5 square. 13 square, that is 169. BE square plus 25. Transfer it. 169 minus 25 equals to BE square. 144 equal to BE square, therefore 12 equals to BE. So this is your first step in this sum, applying Pythagoras theorem and finding altitude BE, which is actually the distance between two parallel sides, by applying Pythagoras theorem in this particular triangle. Now dear student, as you got your required, the second step, simple, just to find area of trapezium. Okay, let us write ABCD, that's the area of trapezium. What is the formula, you know? Half into bracket. We are looking for now area of trapezium. Half into bracket AB plus CD into this distance between parallel side, that is BE. Understand the data properly, dear student. In the previous example which we revised in our lecture number 1, there were 4 steps involved. Here only 2 steps. First step is to find the altitude, that means the distance between the two parallel side, and the next step, quite simple, area of trapezium, half multiplied by AB is given 13, CD 18 multiplied by BE you found out 12, half into 18 plus 13, understand, 31 into 12, just cancel, 2 6 ja, 6 1 ja 6. This is your final answer. Please look at the steps which we have done in solving this example, because one similar example I just now want to give you as an SLP instantaneously now. Look at the step. Only 2 steps get involved in solving this example. Please look at this. Just have a look. Only 2 steps. One step to find the distance between two parallel sides, and another step just to find the area of trapezium. Okay. Sometime you may not be able to now just write the data which is presented here. Try to understand Pythagoras Theorem, okay, and then as usual, dear student, you know how to solve, okay. One similar example, understand, for self study just now, okay. You please write this by writing number 2. Just write the question. Find the area of trapezium. The question, find the area of trapezium, okay, as shown in the diagram. Then I am drawing the trapezium for you, and you have to target to find its area, okay. Just 2 steps will get involved in solving this complete example, right? Okay. You must have written this. Find the area of trapezium as shown in the diagram, and now I am just drawing the trapezium. You please draw with me. This is trapezium given to you, okay. This is trapezium. Draw the complete diagram with me. Trapezium given ABCD. In this trapezium, this is given 17 centimeter. This is given 15 centimeter, and this is given 23 centimeter. Please write the given data mentioned here and try to solve this example by yourself. I am giving you 5 minutes time to solve this example. Okay? Try to solve this. Two parallel sides are given 15 centimeter and 23 centimeter, and out of the two non-parallel side, one of the non-parallel side has been given 17 centimeter. Please try this sum. Okay? 5 minutes time, and then we'll solve the same example here on the board. Just look at the sum and try to solve it. Draw altitude. Try to find altitude by Pythagoras Theorem as you are already explained. Find the altitude and you will be able to find the area of this trapezium ABCD quite easily. But your concentration has to be on finding altitude, which represent actually the distance between these two parallel sides. That's what you need to target. Dear student, just 2 minutes time now. Just try to solve comfortably in your book, and then we will try to solve the same example here. Just try to solve this. You need to have the complete idea regarding the squares of each and every number. Then and then you are able to solve this example perfectly. Student might sometime have confusion in drawing the trapezium. This is also trapezium, dear student. Just any quadrilateral, stick to the basic properties of trapezium, that one pair of side needs to be parallel and one pair of side needs to be non-parallel. That is sufficient to assign, label it as a trapezium. Okay, that is the only requirement. Okay, Can you solve now? You must have tried yourself. Now I am solving the example here on the board, and you just need to concentrate, okay? See, dear student, as usual, what we do first, we are constructing one altitude. Let us say it. One altitude we have to construct from B, okay, on CD. Let us say it L. After drawing this, some sorting out of measure, this became rectangle where opposite sides are parallel and equal. This is 15 centimeter. This is also 15 centimeter. Total, as you know, 23 centimeter total. 23 minus 15, this comes out to be 8 centimeter. This is actually, we can consider always, though I haven't written, but actually understanding the diagram and acquiring some necessary data for the further calculation of the example is also one of the important steps, because reading diagram is also ultimately a very important concept, okay? Now, dear student, the first step, we will apply Pythagoras theorem. In which triangle can you mention? Triangle BLC, okay? Let me write the first step. According to Pythagoras theorem, in triangle BLC, I said BLC, okay, but Pythagoras, as you all know, and you should practice it more and more, from hypotenuse. BC square equal to, just check the triangle, BC square equal to BL square plus LC square, okay? Let us substitute the value. BC is given 17 square equal to, I am keeping the pace of writing in such a way so that you can be and able to synchronize your speed of writing. BL square plus L square, that is 8 square, square of 17, that is 289, equal to BL square plus 64. Square of up to 20, you should remember I guided you in advance also. 289 equal to BL square plus 64 transfer it. 289 minus 64 equal to BL square. 225 equal to BL square. Take out the square root. 15 equal to BL. So dear student, you got BL equal to 15 centimeter, which is actually you got the distance between both the parallel side. And next, what we are targeting now, second step, area of trapezium ABCD equal to half into bracket sum of parallel side into distance between the parallel side. So let us substitute the value. Half into AB was given 15, CD 23, BL you found as 15, okay. Half into 15 plus 23, 38 into 15. Just cancel this. Now simply multiply this. Okay. And you got the final answer 285 square centimeters. See, with the example you have already solved in your book, just verify and try to verify the sum I have written here. How to find the area of trapezium when it is given in such format, in the form of diagram. So you need to concentrate here. One of the non-parallel side is given. How to find the altitude, that means the distance between two parallel sides, by application of Pythagoras Theorem. Dear student, you must have written the sum. You understood one thing. Lecture 1 of revision and lecture 2 of revision, in both the lecture, I spoke one very important statement: stick to the basics. And what is the basic is telling? When you want to find the area of trapezium, you should have length of both the parallel side. Not only that, you should know the distance between both the parallel side. In previous lecture, we also targeted to find the distance between two parallel sides, where also we tried to construct a triangle. Here also we tried to construct the triangle, but there, because it was not a right angle triangle, we first found the area by Heron's formula. Then we applied another formula of area of triangle, half altitude into base, and we were able to find the altitude. Here also, dear student, conceptually you are moving similar. Here also you are targeting altitude, but here little different way, because just by drawing an altitude you are already getting a right angle triangle, and once you get the right angle triangle you can apply Pythagoras principle and find this altitude, that is the distance between the two parallel side. Okay, two example of similar type we have discussed in today's lecture. Okay, practice some more example, find from 10.1 and also try to solve it by yourself. Okay dear student, target of revision lecture is always to boost your confidence and make your basics very clear. You understood this? Okay, thank you very much.